We're doing a deep dive today on a piece of hardware with a name that only an engineer could love. Get ready for this. The NTI HD4K18GB-FO-30M-MM.
Wow. Rolls right off the tongue, doesn't it?
It really doesn't. But, okay, let's get to the chase. This is a 30-meter HDMI cable, and it's listed for $222.
Yeah.
That's a serious price for a wire. So our mission here is to unpack why. Why does a single cable cost as much as a small TV, and what exactly is this active optical tech doing?
Well, the price starts to make sense when you realize it's not really a wire. Not in the way we usually think of one.
It's an active optical cable.
Exactly. And at that price, you're not paying for, plastic and copper. You're paying for a tiny fiber optic conversion system that lives inside the connector heads.
Right, because at 30 meters, we're way, way past the limits of what standard copper can do, correct?
Oh, absolutely. That's the physics wall. A normal passive copper HDMI cable starts getting unreliable at around 15 feet, maybe a little more.
And this is for 4K video.
For a full 18 gigabits per second, which you need for 4K at 60 hertz, pushing that over 30 meters, you just can't do it with metal alone. You have to use light.
So if we were to cut this thing open, we're looking at a hybrid setup.
That's it. It'd have 4 fiber optic cores inside, and those are doing all the heavy lifting for the high-speed video. Because it's light, you get what the specs call zero signal loss. It's basically instantaneous.
But it's not just fiber. I see it also has 7 copper conductors in there. I'm assuming that's for the low bandwidth stuff.
Precisely. The copper is there to handle the data handshake. Telling the TV what the source is, handling the remote control signals.
Your CEC and DDC data.
That stuff doesn't need huge bandwidth, so copper is perfectly fine for that. And for power.
It's just impressive engineering, especially when you look at the form factor. The spec sheet says this is only 4.5 millimeters thick.
Yeah, it's tiny.
And it has a bend radius of 48 millimeters. Usually a hybrid cable sounds like it's going to be this thick, stiff thing.
And that flexibility is so important for installers. You have to be able to snake this through a wall or behind equipment without, snapping the glass inside.
Okay, speaking of the install, I'm looking at the power specs. Usually, active cables like this need a little USB plug or a wall adapter to power the chips. This one says, requires no external power supply. So, how?
It's actually a very clever, elegant solution. It siphons power directly from pin 18 to the HDMI port itself. It just draws the plus 5 volts it needs from the source device. It keeps the whole setup really clean. But there is a catch.
Let me guess. If the source device is a little weak on its power output.
The cable goes dark.
Yeah.
Exactly. It needs over 500 milliamps. If you plug this into, say, an old laptop or some cheap splitter that doesn't push enough current on pin 18, this $200 cable just won't light up.
That is really good to know. Okay, so beyond just the distance, the other big selling point here is immunity to noise, right? In a busy environment, a 30-meter copper cable is basically just a giant antenna.
That's the huge problem, yeah. Copper picks up everything. EMI, RFI. If you're running a long cable through a ceiling near power lines or fluorescent lights, that noise can just destroy the digital signal.
Which explains why the use cases here go way beyond a fancy home theater.
Right. Think about medical imaging. An MRI machine is a giant electromagnet. You can't run a normal copper video cable for a 4K display in that room. The image would be a mess.
But fiber is just glass. It's completely immune.
It's immune. Same logic applies to airplanes with all their electronics or factory floors with heavy machinery. Anywhere you need perfect signal integrity over a long distance in a noisy environment.
So at the end of the day, what you're really paying for is reliability. You're paying to make sure that physics doesn't interfere with your movie night or, your brain surgery.
That's a perfect summary. It takes the massive data load of Ultra HD and just removes the physical limits of copper.
It really makes you think about all the invisible infrastructure needed just to get an image on a screen. We always focus on the TV itself, the panel, the processor. But sometimes the most advanced piece of tech in the room is the wire you never even see.
And often, that wire is the difference between a crystal clear image and, a blank screen.